My name's Andy Frazak, owner of Frazak Solutions, LLC, consulting industry. Today, we're going to be talking about the Internet of Things project for the Suncoast Innovation Challenge. Part 1 of this deliverable will demonstrate my understanding of IoT, and it will also explain how that aligns with the problem of interest. I will provide a clear and concise understanding of how the two are interrelated. This project will illuminate findings by best way of practices, strategies, and tactics by and through the role of technology, cost structure, other cases, and how and why this area requires growth. IoT, also known as Internet of Things, is becoming a widely popular approach to problem resolution in various aspects of the marketplace. IoT allows us to enhance the way we collaborate within groups to resolve issues. We no longer lead a lifestyle where strategizing sessions take place on a chalkboard. Interactive tools like smartboards, online collaboration, geared softwares, and portals were formulated so we can communicate on a global scale if we wanted to with one another to resolve issues and exchange business methodologies. As it relates, the technological advancements did not stop there. IoT is also a blend of unique components, data analytics, sensors, user goods that enhance how we live life. It enables robotics and machinery to complete tasks without human intervention. IoT and the presence of microplastics are interrelated. The topic provides an opportunity for product optimization while collectively reducing a harmful irritant within our waters. While this problem is deeply concerning, unfortunately, there are no known competitors identified in the Tampa Bay region. No one has yet created a way to resolve this issue, which is exceptionally opportunistic. The issue of microplastics have been a long-time problem, both globally and nationally. As it relates, this piece of data has only surfaced itself in 2019 by Kinsley McEachin, an environmental scientist and policy graduate from the University of South Florida here in St. Pete. McEachin's water sample from the Tampa Bay has identified, since particles are similar in size to plankton, filter feeders such as oysters, clams, many fish, and some birds ingest microplastics, allowing them to enter the food chain. Persistent organic pollutants, including toxic pesticides and metals, can stick to their surfaces, making ingestion potentially that much more damaging. Effects including cellular damage and reproductive disruption and death. The study revealed that the predominant type of these tiny particles in Tampa Bay in both the water and sediment are thread-like fibers from fishing lines, nets, and washing clothes. Synthetic fibers are released from clothes while they're being laundered, discharged to wastewater treatment plants, and then eventually released into the bay. In the next segment, there is a graphical model that is reflective of any and all contributors to the growing problem of microplastics, illustrative of the idea behind the slew of untapped possibilities and potential for resolution. According to McEachin, one of the main culprits for microplastics in Tampa Bay is remnants from fishing lines and nets and wastewater discharge. In other words, microplastics for us is coupled with two major concepts: overfishing and wastewater treatment plants mishandling. The focus of this next section will be on comparing and contrasting the suffrage of other regions that also have waters plagued by microplastics. Chicago, Illinois was an area of interest provided their most urbanized river had levels comparable, if not higher, than some of the oceans for microplastic detection. The North Shore Channel in Chicago, Illinois is specifically what is being evaluated. Treated wastewater effluent from the Terrence J. O'Brien Water Reclamation Plant flows into the North Shore Channel, approximately 5.6 kilometers upstream of its confluence with the Chicago River. The O'Brien plant is an activated sludge plant that treats domestic wastewater. It has an average flow of 927 million liters per day, and effluent is not disinfected prior to release. The NSC is part of the hydrologically complex Chicago area waterway system, which is highly urbanized and contains several large wastewater treatment plants. Chicago area wastewater systems drains into the Illinois River then the Mississippi River, it may thereby introduce microplastics to downstream river and marine environments. Chicago, Illinois, and the North Shore Channel are advantageous to compare to the Tampa Bay region for the following reasons. One, they too are finding that the culprit of the issues is wastewater treatment plants and the mishandling of the water that continues to get redeposited repeatedly back into the already infected waters. Number two, similarly, 9.3% of their water effluent from upstream from the wastewater treatment plant contains fibers, just like us here in Tampa Bay. Number three, this particular sample captures multiple affected waterways. It's connected to the Mississippi River, whose water and marine ecosystems will suffer by the decision makers of Chicago, Illinois wastewater treatment plant facilities. Number four, Chicago, Illinois rivers, and it looks like Mississippi River too, both have presence of microplastic, but levels particularly close to concentrations that we see here in Tampa Bay. Around 4 billion particles worth, and Chicago, Illinois specifically at about 5 billion particles worth. So they actually have higher levels than we do, and we're talking about oceans compared to lakes. There is a huge value proposition involved in Chicago, Illinois to resolving this issue, provided that other Great Lakes are being impacted by their policymaker decisions. If they were to resolve these issues, then this can build a multifold impact. For example, if Chicago, Illinois understands the threat of microplastics and develops a plan, execution on this also would benefit the state of Mississippi and several others where the Mississippi River flows through, where the microplastic remnants are flowing into from Chicago's tainted waters. How is Chicago, Illinois solving this issue? So far, Chicago, Illinois continues to track the issue, just like McEachern here in Tampa. They're also using nets to manually collect water samples and evaluate them. They're also using what is referred to as mobile power soil DNA extraction kits to collect microplastics and organic matter samples. This system enables them to measure the issue, quantify it qualitatively, and analyze the results. Appropriately monitoring and controlling the issue is critical. This activity only has meaning when you develop a baseline for acceptability thresholds and how you want to measure those variances along the way. The way their environmental scientists have developed what seems to be efficient and functional seems to be working. Now I'd like to challenge the assertion, is this way the best practice? Is Chicago, Illinois handling this issue with the most convenient and efficient way? I think the next segment will expound upon methods utilized in other regions and how that is measured against Chicago and Tampa-based collection measurement systems. In 2021, California legislature passed a Senate Bill 1422 that mandated State Water Board develop a testing for microplastics due to scientific evidence that has come to surface. Research shows that they use a system called Raman spectroscopy. Let's elaborate a little further. What is Raman spectroscopy? This is gaining ground in the analysis of microplastics, especially due to its high spatial resolution that allows the investigation of small plastic particles whose numeric abundance is argued to be particularly relevant in the aquatic systems. Here, we aimed at outlining the status of Raman analysis of microplastics from the aquatic systems, highlighting the advantages and the drawbacks of this technique, and critically presenting tools and ways to effectively employ this instrument and to improve the spectra obtained and their interpretation. In particular, we summarized procedural information for the use of Raman spectroscopy, and we discussed issues linked to fluorescence interference and the analysis of weathered polymers, which may complicate the interpretation of the Raman signatures. In this context, a deep understanding of the different plastic polymers and their Raman peaks and chemical fingerprints is fundamental to avoid misidentification. So this is basically a piece of technology that robotically goes in the water to identify microplastics. So far, the system is flawed in that it is impacted by fluorescence, and the analysis then comes back inaccurate. Overall, I'd like to challenge, is that the best practice? Well, before being able to resolve any problem with Internet of Things, knowing how we can measure it and if that practice is suitable must first be a priority. For evidentiary purposes, creating an instrument that allows Raman spectroscopy to evaluate the scope of the problem is seemingly ineffective. It is also not cost-effective to technologically manufacture and produce a device that cannot properly detect the presence of microplastics due to the infrared interference. This brings me back to the original collection processes being used in the Tampa Bay and Illinois areas. While these processes may seem a bit dated, it is more accurate currently. What is captured in the nets and brought back to the lab for further DNA extraction and evaluation is more authentic than an expensive device that brings back insufficient data. The final piece of this brief I'll address is identifying technology or infrastructure needs, early costs, and resources that may be needed. A feed design schedule is most appropriate in this circumstance. Subject matter experts like an engineer, scientist, or environmentalist will need to be the main human resource. Helping to identify costs associated with these types of individuals to make recommendations will need to be the starting place. Acquiring costs associated with anything beyond that, such as resources or technology, would simply be inefficient at this level without having access to further data, which would be provided by said experts.
One of the biggest takeaways from this class and the tool that I was given was the framework of each problem. As notated on this slide specifically, it starts with observe and notice, that it goes to reflective observation and getting to the why, frame and reframe, abstract conceptualization, imagine and redesign, active experiment and discovering that how, and make an experiment, all the way down to concrete experience. I think this is helpful for this problem specifically because it helped me to think about what problems we're having here in the Tampa Bay, to identifying the waters and how there's a lot of pollution in the waters and toxins, which led to microplastics. There's the frame and the reframe, and then moving into the imagine and design. What could we do about this? What could we create to do something about this? And then make an experiment, which was the whole section of our prototype and how I compared the robot that I imagined to our competition known as the Raman spectroscopy that I've frequently mentioned, and thought about how we can design our own, a better prototype, a efficient and functional prototype. And in other problems as a consultant, I think that having this generalized framework allows you to start with a basic approach and then scale the problem into a more efficient and affordable answer for the client. And it kind of allows you to let the client or the users see the process that you're following in a broken down piece by piece aspect. This leads me to ask, what should we do about this? How can we create a solution to the problem of microplastics plaguing our water? How can we find a way to get the water sludge facility plants, treatment plants, to be able to somehow sanitize the sludge before depositing it into the water? How can we find a way to detect the microplastics in the water? How many microplastics are in our water? How much? What's the size of this problem? As you can see, that the Mississippi River that branches out to several other states and regions, they're having a problem with microplastics too, which means not only us in Tampa Bay are experiencing this problem. People who are connected at all or within proximity of the Mississippi River are also suffering from this issue. So what economic policy, specifically here in Florida, could be put in place? They could maybe, just maybe, touch other regions and help them too. But more specifically here in the Suncoast region, how can we possibly turn this story of our waters being plagued with microplastics and eliminating our ability to use them for recreation and fishing to the best of our ability? How can we make our water safe again? Now that we know what works with the Raman spectroscopy that was developed by our competition, we'll be able to take the features of it and have preservation over those features as we more quickly create our own robot. It's helpful to look to our competition to identify what works and what doesn't. Having preservations over the features that do work And then taking them an extra step to perhaps work even better than our competitors did is a way of being innovative and creative while also finding a way to change the economy and see that global shift that we're working towards with that liberal economic policy. We want the increased ease of access with our creation. We want our scientists and our marine biologists to be able to throw this device into the water and have it be able to easily collect and transmit the data back into the software while the robot collectively speaks to them while being able to pick up on the detection of microplastics. How does all of this connect to some of the tools that we learned in scalability? There was a slide about what is scalability and why is it important. In this slide, it focused on creating a growing mismatch between the original drive for scalable efficiency and the business needs of companies today. The scalable efficiency models that work so well in times of stability became dysfunctional when the forecasts and predictions that drive the very specified, tightly integrated, and highly standardized process of large firms become more and more challenging. The need to redeploy people and assets at the last minute to address unanticipated events make a previously efficient system highly inefficient. So this correlates to my project in such a way that when we reference the Raman spectroscopy system, that was a robotic device that was used to detect microplastics in the water, was found to be ineffective. And so today we need to be more innovative and creative in how we're creating this robotic technical device that we're tossing into the water to be able to trace the amounts of microplastics that are plaguing our waters. And the reason the Raman spectroscopy didn't work is because the infrared rays that it was giving off was creating an issue with accuracy. They also had a recording thing that they put on the robot. And when recording, it caused the motor to rotate. And when it rotated, it created a grading error. So it wasn't grading the land properly under the ocean. And when it was at such an angle, it was missing certain scraps of microplastics and was not picking it up. So we need to create a machine that doesn't have infrared light that is going to interfere with its ability to transmit data and collect it. We need to create a device that does not have anything that is going to affect its ability to properly capture and collect that data, even when the recording device activates on. While an important feature to be able to record while collecting data real time, we can have a device that is obviously going to bring us back inaccurate information. In order to solve a problem, we need to be able to quantify it. And any problem that needs to be properly managed first has to start with measuring the problem in size first. So what I will say to wrap up is the solution is let's find a team of manufacturers and engineers first so we can address this. Let's create a project charter so that we can address all the major details from planning, execution, monitoring, and controlling and identifying stakeholders in the manner. We'll need to develop a workable budget to ensure that the costs associated with such creation is affordable. We will need to look up investors to identify who can we pitch this to, help us clean up some of the costs. After all, creating a feel-good product that the community as a whole will benefit from should not be too daunting of a task if stakeholder engagement is conducted properly. The ultimate goal is to create a robot who is waterproof, that he can go into the water to identify the presence of microplastics. This robot will require state-of-the-art sensors for our technology so that we can ensure that our robot is collecting the right amount of information. We want the robot to collect the quantitative data for us and design him in such a way that allows the estimates to be as close to exact values as possible. The robot will speak directly to a software system that translates the data in real time and uploads its findings autonomously. This eliminates the need for manual data input. Manual DNA extraction with the myobio kits that were being used previously are outdated. This allows us to focus more on improving the quality of our water that is being plagued with these microplastics. Having a robot to complete these tasks for us reduces the overhead involved. People going through with these kits and manually doing it just eats away at the labor hours. Having a way to collect water samples by net and take them back to the lab and analyze those findings, employees such as scientists and environmentalists are not cheap, and they will log the man hours using such a dated strategy. This will utilize the approach known as the Internet of Things to have a more modern-day, advanced, yet convenient way to derive this data. Overall, I think that being able to take full advantage of the technology has to offer us is the most sustainable. After all, businesses of all kinds have a budget in mind, no matter how the revenue stream is that they have. Developing pathways for them to better allow them to spend their budget more efficiently is the ultimate goal, and this allows them to do that. Optimizing operations to be more technologically based enables firms to focus on generating solutions and moving away from all of the excess costs affiliated with manual labor that only allows them to forecast how deep the damage is of the issue, not including the cost of strategy implementation around how to even solve it.